All right, so here we have some dobros that we're selling, and we want to answer some questions about Sweet Harmony Crafts. Here we got X is the hundreds of dobos that are to be built, and the average cost is given by this function. C is in hundreds of dollars, so keep that in mind here. So we have 600 dobros we want the cost for, so we want to let X equals 6. So we're going to compute that. C of 6 equals 0.1 times 6 squared minus 0.7 times 6 plus 2.425. Just punch on your calculator, see what you get. And that gives us 1.825. 1.825. So that's 1.825 hundreds dobros. Hundreds. So we could just move the decimal point 2 places, and that's 182.5 dobros. All right. Not too tough there. Now we want to know when the cost will be $300. Okay, so that's 3 is what we want C to be. So let's go ahead and write our function. We want 3 to be equal to 0.1 x squared minus 0.7x plus 2.425. All right, so we're going to set this equal to 0. It's a quadratic equation. Going to use a quadratic formula. One thing we can do right now is we can multiply everything by 10. That makes life a little easier. Just kind of gets rid of that decimal point. This is totally optional, but it works nice. 30 equals, distribute the 10 out. We have 1x squared minus 7x plus 24.25. Subtract that 30 from both sides, and we have 1x squared minus 7x and negative 5.75. Now it's time to go to the quadratic formula. So we have x equals negative b, which is going to be negative 7, positive 7, plus or minus the square root of negative 7 squared minus 4 times a times c, negative 5.75, okay, all over 2a. Okay, so let's just crank that out. Well, let's do the discriminant first there underneath the radical. And it actually comes out pretty nice. 7 plus or minus the square root of 72 all over 2. Now, if you did this without, by the way, if you did it without multiplying by 10 up above, yeah, this would still work. It would just be some decimals in here, but it still works. And so here, this is an application problem, so we can just simplify it here. We've got two possibilities, 7 plus the square root of 72 all over 2, or 7 minus the square root of 72 over 2. Now, this last one here is going to be negative, so we can just throw that out. Punch in your calculator, it's going to be negative, because square root of 72 is bigger than 7, so that's going to be negative. The positive one comes out to about 7.7426, and we notice that that is the cost in hundreds. So remember up top it said the cost was in hundreds. So move the decimal 2 places. That's 774.26. So we can say that we have about 774 dobros. Okay, so when we're making that many dobros, then that cost will be about $300. Okay. All right, and last one here, we want to find out what the minimum average cost per dobro would be. Now this is a minimum because this quadratic function here, We know the graph is a parabola. This A value is positive, so it's opening up. So it's some graph that looks like this. And somewhere there's a minimum. We need to find the vertex. Whenever we're looking for minimum, we're looking for the vertex. So what we need to find is we need to find the vertex. So let's start with the axis symmetry. X equals negative b over 2a. Negative b, which is negative 0.7 over 2 times a, which is 2 times 0.1, which is going to be 0.7 over 0.2. Let's multiply top and bottom by 10, and that comes out to be 7/2, which is 3.5. So 3.5, when x is 3.5, we have our vertex. So the question is, what is the average cost and at how many dobros? So x here is 3.5, which is 350 dobros, because this is in hundreds. Okay. That's what x is. And the minimum average cost, we got to just plug that back in and figure out what it is. So we plug in 3.5, and we're going to crank it out. Let's see what we get. And that comes out to be 1.2. Okay, which means that's hundreds of dollars. So $120 is the minimum average cost. All right. So the company wants to make an average of 350 dobros to get the minimum cost. There you have it. Remember, whenever we're talking minimum or maximum, we're looking for the vertex. That's a super important one there. Okay?